Again, JEE Advanced 2018, paper 1, question number 3. But this is going to be a very easy question for you. See, the question is very elaborate. Valiya question aanu. A uniform capillary tube of inner radius R is dipped vertically into a beaker filled with water. So let us consider a beaker here, and we need a capillary tube inserted here. Okay. Now, okay, the tube must be open on both the ends. So I'll just erase the lower portion. Yeah. And there is water in the tank. Okay. The water rises to a height h in the capillary tube. So this rises to a height h in the capillary tube, above the water surface. The angle of contact between water and the wall of the capillary tube is theta. It's called angle of contact. Ignore mass of water in the meniscus. Which of the following statement is or are true? See, this question is 4 options based on this equation H equal to 2 surface tension sigma cos theta divided by radius of the tube density of water into G. Question number A പറയുന്നത്, for a given material of the capillary tube, H decreases with the increase in R. Relation between H and R. H and R relation for a given material. See, it is water. It is water. So naturally, surface tension of water constant aanu, density of water constant aanu, acceleration due to gravity constant aanu. This cos theta will depend on the material of the tube. So if you change the tube, that angle theta will vary. But here it is given particular material. That means cos theta is also going to be constant. So nokanam ivide 2 sigma cos theta rho g constant aanengil, how is H and R related? Inversely proportional aanu. So what will happen? When R increases, H decreases. Means wider tube will height koravaarikkum. So option 1 is a correct statement. Okay. Second one, for a given material of the capillary tube, H is independent of sigma. No. See, given material means theta constant aanu, but of course H will depend on surface tension. Clear? So naturally, this option is not correct. Surface tension, like we know, if you take a mercury, it will have a capillary fall, water capillary rise, it all depends on the surface tension. So it depends on option B theta. Option C nokanam, if this experiment is performed in a lift going up with constant acceleration, even a lift is going up with constant acceleration, endu cheyanam, endu maatama varune, ee G plus A aakanam idine. G ku pagaram G plus A, upward acceleration aanu. Naturally, when you accelerate it, H decreases. That's the correct. So when you accelerate it upward, H koravaarikkum. H is proportional to contact angle theta aanu. H proportional to theta allallo. H proportional to cos theta. So here option D theta. So you can say option A is correct, option C is correct. A and C are the 2 correct options. In another point, this tube rise mass, the mass of the liquid in the tube. That is related. Mass is proportional to radius. If you double the radius of the tube, mass will also double. Right. Now, if you perform this in a freely falling lift, what will happen? A freely falling lift is G plus A is G minus G. That means H tend to become infinity. That means the water will fill the entire length of the tube when it is freely falling. Another question is, what will happen if you cut the tube? Because this is height H rise. What will happen if you cut the tube here? Will it flow out? Will this flow out? It will not flow out. Our point le flow out cheyilla. Adinte meniscus inde radius increase cheyum. That means അതായത് നേരത്തെ ട്യൂബിലെ meniscus ഇങ്ങനെ ആണെങ്കിൽ അത് കുറച്ചുകൂടെ ഫ്ലാറ്റ് ആവും. അതിന്റെ meniscusന്റെ റേഡിയസ് ഇൻക്രീസ് ചെയ്യും. ഇൻസഫിഷ്യന്റ് ലെങ്ത് ആണെങ്കിൽ. So these are the additional points that you can keep in mind while solving this question. Thank you for this.